Hello. In today's video, we will be discussing melting point and boiling point and talking about how these properties can be used to identify and differentiate between substances. The melting point of a substance is the temperature at which that substance will melt or freeze. Every pure substance has its own unique melting point, meaning that is the only substance on Earth that has that exact melting point. Because it is unique to every substance, a substance's melting point is like a fingerprint and can be used to identify it and to differentiate or tell it apart from other substances. As I said, the melting point is the temperature at which a substance will melt or freeze. As a reminder, melting is the transition of a substance from the solid phase to the liquid phase. Melting will happen when melting point temperature is reached and then gone above, or thermal energy is added to the substance. On the other hand, freezing, which is the transition from a liquid to a solid, will begin to occur if the substance's temperature begins to go below the melting point or thermal energy is removed from the substance. In order to determine the melting point of a substance, we must take that substance in its solid state and heat it until it begins to transition to a liquid. When it begins to transition to a liquid, we record the temperature, and that will represent the substance's melting point. This can be done with a melting point apparatus or more simple means. Melting point apparatus, as shown here, is simply a fancy device that takes a small sample of a substance and heats it and heats it and heats it until you begin to see it melt, and you can stop and note the temperature at which that started to happen. We can also just do this in a more simple way by heating a solid substance using something like a hot plate or a Bunsen burner and a thermometer, and noting at what temperature the substance began to go from solid to liquid. And we know that melting point is a property of matter that can be used to identify substances because every pure substance has its own unique melting point, just like a fingerprint. This is unique to that substance and can therefore be used to identify it. There are really only two options here. First, we can have a situation where two substances have the same melting point, just like two unknown people having the same fingerprint. This tells me that yes, they are the same substance because their fingerprint is the same, or this property of melting point is the same. On the other hand, if we have two samples and we find that they have different melting points, that tells me that these are not the same substance and they represent two different substances. Now let's look at an example of using the melting point to identify substances. In this example, it looks like there are two unidentified silver metal blocks in Mrs. Santiago's classroom, but neither of them are labeled. So Lulu is asked to determine whether the two metals are the same or different. So she, knowing and understanding properties of matter, collects the following data. We can see that Lulu has collected the melting point in degrees Celsius of both metals. We can see that metal 1 has a melting point of 660.3 degrees Celsius, or metal 2's melting point is 650 degrees Celsius. Take a minute to pause the video and answer what you can determine about the identity of the two substances. Hopefully you paused the video and were able to conclude that because the melting point of these two samples are different, that tells Lulu and all of us that these substances are different because they do not have the same melting point. Next, we'll talk about the boiling point. Boiling point is the temperature at which a substance will boil and then evaporate. Just like a melting point, every pure substance has its own unique boiling point, which can be used to identify it, just like a fingerprint. Thinking back to Unit 1, we know that evaporation is the transition from the liquid state to the gaseous state. Evaporation will start to occur if and when the temperature meets and then goes above the boiling point by thermal energy being added. So as I add more thermal energy and the temperature of a liquid rises, eventually it will begin to transition into the gaseous state. In order to determine a sample's boiling point, we would take a liquid sample and heat it until it begins to transition to a gas. We would, of course, note the temperature using a thermometer at which that transition began to happen, and that would represent that substance's boiling point. Just like a melting point, a boiling point, again, can be used to identify substances because every pure substance has its own unique boiling point. Because it's unique to that substance, like a fingerprint, it can be used to identify that substance or tell it apart from other substances. We could have an instance where we look at two substances and find that they have the same boiling point. That tells me that they must be the same substance. On the other hand, we can have two samples and find that each of those substances have different boiling points. That tells me that they cannot be the same substance because they don't have that same identifying fingerprint of the boiling point. Let's look at one more example. It looks here like there are two bottles of clear liquid in the lab at the NIH, or the National Institute of Health. Scientists want to know whether the substances are the same or different. Luckily, DJ is there, and he's a chemical engineering intern. So he decides to test the boiling point and collects the data that we see here to try to find out what he can determine about the identity of the substances. We can see that liquid 1 has a boiling point of 100 degrees Celsius, and liquid 2 has a boiling point of negative 59 degrees Celsius. Take another minute to pause the video and determine what you can say about the identity of these substances. Of course, you would have said that the boiling points of these two substances are different, meaning that they have different fingerprints or different properties, which tells us that these cannot be the same substance, and in fact, they must be two different substances.